Level 4, the most difficult problems, it's when you have a double radical problem. Take a look at problem 5. In problem 5, I'm going to solve it using the quadratic formula and not with factoring for those who like the quadratic formula better. Now what I want you to know is if we have two square roots, we have a big square root here and kind of a smaller square root here. When this happens, please get the big square root all by itself. So get this one all by itself, okay? Move the other one to the other side. So I'm going to add the square root of x to both sides. Now, my new problem is going to be the square root of 2x plus 1 equals 1 plus the square root of x. These problems are probably the most painful problems of the day because we have a double square root to deal with. So get the big square root by itself and please square both sides just like we have been doing. This side squared is going to be really easy. It's just going to pop out of the square root and become 2x minus 1. So if you're writing down steps, this is where we squared both sides. Okay. This side will not be as easy. We need to write it twice. Do not make the mistake of distributing in the squared because you will be wrong. Okay, carry down the 2x plus 1 and get ready for some, I guess I'll call it fun. Okay, 4 arcs, 1, 2, 3, 4. Apply the rules you've learned thus far in chapter 6. 1 times 1 is 1. 1 times the square root of x is 1 square root of x. 1 times the square root of x is 1 square root of x again. The square root of x times the square root of x is the square root of x squared. Now it's time to simplify. This side remains 2x plus 1. Well, this stays a 1. These two get put together to become 2 square roots of x when you combine your like terms. And this is just x because you have enough x's to pull 1 out. Now what I want you to do is I want you to look and I want you to evaluate this problem. Do you see how you have a term with a square root inside of it? That's the term that you need to get by itself. So I need to take this 1 to the other side and I need to take this x to the other side. So here's the 1 to the other side, here's the x to the other side. So that's 2x minus x makes a regular x. Conveniently, the 1's cancel out. That does not always happen. And that will equal 2 square roots of x. This problem really isn't as bad as I thought it was going to be. The next thing we're going to do is we have the square root term by itself. Again, we need to square both sides. So on these ones, you're going to have to end up squaring both sides twice when you have a double square root problem. So this side squared and this side squared. So this side squared is just x. Now this side I don't really have to write it twice because it's a monomial. There's not a plus sign in the middle of it. So 2 squared is just 4. You can distribute your squared in. And that becomes the square root of x squared. Or just 4 and pull out the x. Oh, I lost my squared on this guy right here. Now, because we have x squared and we have 4x, I'm going to set it equal to 0 because I haven't set equal to 0 because I have an x squared. I will do the quadratic formula for those of you who like the quadratic formula. So I'm going to have x squared minus 4x equals 0. I had to take the 4x to the other side. That's why it's an x squared minus 4x. Okay, quadratic formula is opposite b plus or minus the square root of b squared is 16 minus 4 times a times c. C is 0 in this case because there's no term in the back. All over 2 times a. Working the quadratic formula out a little further, that's 4 plus or minus the square root of 16 all over 2. Working the quadratic formula out even more, that's 4 plus or minus 4 over 2. That's 4 plus 4, so that's 8 over 2, and 4 minus 4 is 0 over 2. My two answers are therefore 4 and 0. Now those are my x answers. I know it doesn't seem like fun, but you do have to check them both in to make sure they're both viable answers. All right, so I have 4 and 0 to check back in. So I'll do my check right here. The first thing I'm going to do is check out 4. So every time I see an x, I'm going to make it a 4. So I'm using the original. and it says that I need to get a 1 in this problem. So I just took out the x's and I'm checking in 4. Let's check with the calculator. So the square root of 2 times 4 plus 1 on the outside, so another minus the square root of 4. If I get 1, there it is. I know that I have a correct answer in 4. Very good. Now I'm going to check 0. So every time I had an x, I'm going to put in 0. So 2 times 0 plus 1 minus the square root of 0. And again, they want me to get 1. So let's check this out. Square root of 2 times 0 plus 1 minus the square root of 0 is still 1. So I know that I did a good job and that both answers are solutions because they both checked back in. So I can write an and symbol and I don't have to cross anything out. I will do this problem up here. It's the exact same type of problem, but this time I'll do it using factoring. If you like the quadratic formula, just use the quadratic formula. One more problem like that and we'll be all done. Circle the more difficult radical and isolate that. So step 1, get the more difficult radical by itself. That becomes a positive square root of x when you move it to the other side. Step 2, square both sides. That gives you 5x plus 4 on the right, but on the left, be careful because it's going to be x squared root of x plus 4 times the square root of x plus 4. Step 3, multiply things through. So I get 5x plus 4 equals, now FOIL over here. The square root of x times the square root of x is just x plus 4 square roots of x plus 4 square roots of x. That come from the outside and the insides, plus 16. Step 4, combine your like terms. You don't need to make that a step, just make sure you do it if you don't want to write that down. 5x plus 4 equals x plus there's 8 square roots of x plus 16. Step 5, you see how you still have this square root left? That means you have to isolate. Isolate square root. And that came from the beginning of the lesson when I told you your main idea is to isolate your radical. If possible, always isolate your radical. I'm going to isolate my radical. I need to take away x and I need to take away 16 on both sides. So that's going to give me 4x minus 12 equals 8 square roots of x. At this point, if you want to divide by 4, since everything does divide by 4, you may. I'm not quite sure if you do that on your own though, so I'm not going to do it. Okay, so step 6, square both sides again. Now this side is going to be a little more difficult to square because it's a binomial. This side's not going to be hard, you're just going to get 64x. When I square this side, I get 4x minus 12 and another 4x minus 12 that we're going to have to FOIL. Okay, so 4x times 4x is 16x squared. 4x times negative 12 is minus 48x, minus 48x again, plus 144. And that just comes from multiplying your binomials together. That equals 64x. Step 7. You see how you have an x squared? You got to set it equal to 0 then. Alright, so I'm going to bring this 64 over. So I'm going to minus 64 from both sides. Okay, so minus 64x here. Now remember, when you take 64 away, all of these items have to get put together. All of the regular x's, okay? So you have negative 48, you have another minus 48, and now you have your minus 64, so we have minus 160x. So 16x squared minus 160x plus 144 equals 0. Now if we go back up here, this would be a pain to factor. So what I'm going to do is I'm going to go way up. I'm going to divide everything by 16 because it's going to make it easier. So write divide by 16 to make easier. Okay, so that gives me x squared minus 10x plus 9 equals 0. Okay, all I did is I divided everything by 16. Step 9, I need to factor. If I can. If I can't factor, I need to use the quadratic formula, so let's put that on there. Or the quadratic formula. This one does factor nicely to minus 1 and minus 9. Step 10 is to solve. X minus 1 equals 0, x minus 9 equals 0. So x equals 1 and x equals 9. Now we've got to check these to see if they are both solutions. So we'll do the square root of 5 times, let's check 1 first. And I'm just getting this equation from the very top. Minus the square root of 1, let's see if that equals 4. Well, this turns into the square root of 9 minus the square root of 1. That turns into 3 minus 1. So, does 3 minus 1 equal 4? No. 1 is not a solution. So let's check 9. So I do the square root of 5 times 9 plus 4. Then I have to subtract the square root of 9, and we're going to see if that equals 4. 5 times 9 is 45, plus 4 is the square root of 49, minus the square root of 9. That's really 7 minus 3. 7 minus 3 equal 4? Yes. X does equal 9.